Okay, now I have the time it takes for that tumble buggy to move 1 meter, 2 meters, 3 meters, 4 meters, and 5 meters. I'm going to plug in those times here. They go along with each set of distance. So for 1 meter, it took my tumble buggy 2.74 seconds. If I hit enter or move on with the arrow keys or click somewhere else, that'll keep that value in there. Ooh, and something just happened here. This is going to look bad at first because Google Sheets can do calculations for us in addition to a lot of other things. Speed is the calculation of distance divided by time. And I have these boxes set up to be ready to take distance divided by time once it has the data. Now, right now it has the distance, but not the time it takes, so it can't really divide out what we want it to. So it's giving me this error here. Up here, you can see how I made the equation, and we'll talk about that later. But for now, we're just going to use it and benefit from the magic of it. So if I type in my time for 2 meters here, 5.24 seconds, and I move on to another box, like I hit enter, click somewhere else, it calculates the speed for me again. It took 2.0 divided by 5.24, and it got me 0.3816, on and on and on. And you can plug this into a calculator and double check it and make sure it works correctly. Uh, for 3 meters, this took 8.15 seconds. For 4 meters, it took 10.63 seconds. And for 5 meters, it took 13.49 seconds. Now, I said that the tumble buggy moves at a pretty constant speed. And if you're looking at the speed values here, that's mostly true. Like, these are all hovering around 0.36 to 0.38 meters per second, which is not bad. That's pretty close. However, there is some human error associated with how I start and stop the stopwatch, how I watch the starting line and the ending line, how I do those things at the same time. Or if you're working in a group, if you have someone telling you when to start or stop, then that can also lead to errors as well. So, is there a way I can trust one of these values more than the other? Like if it was my job to decide and write on the box or in the product manual how fast this tumble buggy goes in meters per second, could I pick one of these values and say, yes, I think this one I did a better job of being accurate than the others? Well, probably not, because I thought I did pretty well on all of these, but there is a difference significantly between some of these. Again, they're all relatively close, but if I have to pick, do I say 0.36 or 0.38 or something in between? It's kind of hard to pick. Now, we could add these all up and divide by 5 to average out the speed among those 5 trials. But there's actually an even better way we can do that with graphing. Now, let's make a graph out of all these distance and time values to figure out what the real speed of the car is by eliminating the errors that get us these different speeds here. Okay, down below is the instructions for not only marking out the tape for measuring the distance and time for each of your tumble buggy trials, but also how to make the graph up here. So I'm going to walk through how to make the graph, but if you ever need to go back and see the steps, they should be down on the bottom of your sheet, and I'll tell you everything you need to do. So first things first, in order to make a graph out of this data, I need to select the data I want to be able to make the graph out of. All I want is the times taken and the distances. I don't really need the speed included here because we're going to figure out the speed by making this graph. So if I click on a box somewhere in the middle and I drag, I can select multiple of these at once. So that's what I'm going to do. I'm going to click and drag to select some times and distances. The next thing I need to do is make a graph out of this. And all I have to do is go up to insert here, and then I go down to chart. A chart and a graph are basically the same thing. Google Sheets calls it a chart. Depending on what spreadsheet program you're using, it might call it a graph or something else. But we're going to use this chart function, insert chart. Okay, and that kind of gives me something I'm looking for, but there's a couple things wrong with it. For one thing, it's got bars instead of dots, and it is kind of trending upwards, but I also have 2 bars instead of one set of bars that shows distance divided by time. So I've got this axis here, that's just numbers, but it's trying to put time and distance measured both on the same side. I want to have a separate x and y axis. Okay, so to fix all of that, all I'm about to do is just go and change the chart type I have up here. This will a lot of times fix everything you need to worry about that puts your data in the right places. So I don't actually want a column chart. I'm going to change this to having dots that line up with the x and y values, the distances and times. So I need a scatter chart, which has a scattering of dots like this to show where my distances and times line up with each other. So that's what I've got right here. Now I have distance on the y-axis and I've got my time on the x-axis. You can double check that. My distances should go from 0 to about 5 meters. And I should have a time a little past 12 seconds, maybe like up to 13 or 14, which I do. I have a time right there that goes past that. So that looks good to me. So already I've got a graph that puts my distance versus my time. I've got dots that show the individual data points that I took, and I want to eliminate the errors between them by making a line that best fits and shows the trend between those data points. So once I've got my graph and I've got my scattering of dots, I'm done with the setup part, so I'm going to move to customize. By the way, if you ever accidentally lose your chart editor and you're like, I wasn't done with that, just click on your graph a couple times and it will come right back. Okay, so I'm done with setup. I'm going to customize. What I want to customize is called the series, which is a fancy way of saying your values on the y-axis. I want to show the trend between the distances that the car traveled and the time it took for it to travel that far. So I'm customizing the series to show that trend. Now there's all kinds of fun options here, like changing the color. So you can change this to like kind of a purple color. You can change the point shapes. I can do like squares instead of circles. You can make them bigger or smaller. All kinds of stuff. But past all the fun things is a really useful thing. There's just this checkbox here that says trend line, which does exactly what it says. It makes a line that shows the trend. So if I click that, I get a line that goes through these points, not perfectly, because it's not supposed to. It kind of shoots between them, so that the ones that are a little bit too far to the left or a little bit too far to the right aren't dead on here. And the slope of the line itself between those points that have the errors, that have the mistakes in them, will give me a more accurate view of the slope than just picking a single data point or just averaging them up by numbers. Okay, so I'm almost there. I already have the dots, I have the trend line. Now I just have to make Google Sheets tell me what the slope is of this line. Give a number for it. Once you have checked off trend line, you'll get a couple extra options down here. And if I go down a little bit farther, I'm going to go to label, click on this, and say use equation. That is going to put the equation of the line up here at the top. Now, if you have done some math before, you might notice that this looks a little familiar, where you've got a number times x plus some other stuff. The way you write slope in an equation is just like this. Now, this is missing the y equals part of your y equals mx plus b, which is your y value equals your slope times your x value plus your y-intercept, which is what we call b. All I really need to know is the slope here. The rest is just kind of a correction factor and showing that I could put in an x value to figure out what the exact y value is that goes with it. But if I don't really care about how fast the car was going and what distance it could make in like 7 seconds and like kind of connect those from the line there, all I have to do is look at this number in front of the x. This 0.372 is the slope. It's the rise over the run, which means it is the distance divided by the time, which means it is the speed. The slope is the speed, and the slope is the number multiplied to the x. So this is saying that my tumble buggy moved 0.372 meters per second that it was moving. So I've got the speed of my tumble buggy. It's somewhere in between that 0.36 and that 0.38 that I had before just by taking the distance divided by time for all my separate trials. But this should help to eliminate the human error that comes with starting and stopping a stopwatch. So once you have this graph with the trend line going through your scatter points and you've got a slope up at the top by hitting use equation, you're done. You can move this graph, this chart off to the side, and as long as I can find it on there somewhere, you're good to go.